Welcome back, everybody. In our previous lectures, we have taken a look at functions and conditional statements, and we have seen that they can cause the control flow and data flow to get much more complex than our familiar one statement after another execution. So in this lecture, we will explore these ideas further, and we will explore the use of Python Tutor to help us trace through the steps involved when we are dealing with complex code. Also, we will take a look at what we call refute problems. The purpose of refute problems is to help us develop the ability to doubt code. Just because the code looks correct doesn't mean we should completely trust it. We must learn to critically analyze that code, and refute problems will give us practice with this very important skill. We will see that in any refute problem, the code that is given to us is buggy. That means the function doesn't do what it's supposed to do, or in general, the program doesn't do what it's supposed to do. And so we will develop the skill of debugging such code. So let's get started with a simple example, something that we already saw in the previous lecture. We had seen this function that takes two arguments, n and m, both of type integer, and it returns true or false. It returns a Boolean. And this function is trying to check if n is an integer multiple of m. There are more lines between lines 1 and 8, which is the doc string with some doc tests. Since those were covered in a previous lecture, I have hidden those in this view, and we're focusing on the code. We're going to run this code on Python Tutor, and what we will see is that this code is incorrect. And let me tell you ahead of time what the error is that we're going to see when we run the code on Python Tutor. You see, on lines 13 and 14, I call the input function to read in the first and the second integers. And then on line 16, I call the isMultiple function with the arguments a and b. And if that function returns true, remember it's going to return a Boolean. If it returns true, then I say a is a multiple of b. Otherwise, I say a is not a multiple of b. Here I have used the f string formatting, which again we saw in a previous lecture. But do you notice on line 16 these little red squiggly marks? They have been inserted by an additional tool that I have in my IDE, from where I have taken this screenshot. This additional tool is what is called a type checker, and the specific tool I have installed is called MyPy. Now, what have we said? We have said this function expects two integers. But what are the types of variables a and b? Well, a and b are the result of calling the input function, and we know that the input function returns a string. So our MyPy plugin is telling us that on line 16 there is a type mismatch between these two variables a and b. They are referring to string objects, but you promised me in the signature of this function that you were expecting integers. Now, as we shall see when we execute this code on Python Tutor, Python does not catch this error. This is why having a powerful IDE with tools like MyPy is so useful to professional programmers. In this case, the code is simple enough. This error occurred on line 16, and the cause of this error was on line 1. There is a non-trivial gap between lines 1 and 16, but in real-world code, where the program could be millions of lines long, spread across multiple files, it is extremely helpful to have tools like MyPy to help programmers catch such errors. In some ways, it is very good that Python is dynamically typed and you can pass in arguments of any type. But type hinting is useful to catch unintentional errors like this, where I meant to, of course, pass integers, but I forgot to convert these strings into integers before calling the function. So let's execute the code on Python Tutor as it currently is, and then we'll also debug this code. We will get rid of this error.